Greetings to you, dear ones. In this tutorial, I'm going to teach you how to determine the operating voltage of a Zener diode. But before anything else, it's better to have an overall view of the internal structure of a Zener diode. But first of all, it's better to have a general understanding of the internal structure of a Zener diode. As you can see here, a Zener diode looks similar to regular diodes, with the difference that it has a glass body. It is usually brown in color, and is available in various sizes and wattages in the market. A Zener diode, like a regular diode, has a cathode and an anode side. The cathode side of the Zener diode is marked with a black or blue stripe. In some diodes, this stripe is black, like in this diode, and in others it is blue. In any case, the cathode side of Zener diodes is identified by such a stripe. The Zener diode, like a regular diode, can conduct voltage from the anode to the cathode. The voltage required to use the Zener diode in a regular diode mode is 1 volt, allowing it to conduct current and voltage from the anode to the cathode. But the Zener diode has an important difference compared to regular diodes. It can conduct current and voltage in the reverse direction, meaning from the cathode to the anode as well. However, for the Zener diode to conduct current and voltage in the reverse direction, there is a condition. The reverse voltage must reach the breakdown voltage threshold defined for the diode so that the Zener diode can start conducting and allow current to flow in the reverse direction. If this Zener diode is a 5-volt diode, for example, and we apply a reverse voltage of 3.3 volts to the cathode, the diode will not allow the voltage to pass in the reverse direction. However, if we increase the reverse voltage to 5 volts, the diode will allow the voltage to pass and will conduct current in the reverse direction. If we want to take a general look at the internal structure of a Zener diode, we can consider a structure like this. It's as if two diodes are placed in the opposite directions within a single package. As you can see, one of the diodes functions like a regular diode, allowing current and voltage to pass with a forward voltage of 1 volt. And on the other side, in the opposite direction, the current and voltage are allowed to pass, which I have marked with a question mark. Any voltage placed at this question mark will be the operating voltage of the diode at which it can conduct in the reverse direction. This is because Zener diodes are manufactured with different operating voltages. So here you have had a look at the internal structure of a Zener diode. The problem is that the Zener diode is very small and it's difficult to read the numbers on it. So how can we determine the working voltage of the diode? To determine the working voltage of a Zener diode, there is a very simple method. In this method, we will use a multimeter and a DC power supply to measure the Zener diode's working voltage. I will explain how to perform this test on a schematic, and then we will proceed with the practical demonstration. As you can see in this schematic, we will create a simple circuit like this. First, we place a 10 kiloohms resistor and then connect a Zener diode in this way to the resistor's end, creating a series circuit with the resistor and the diode, which means we have connected the resistor and the diode in series. The resistance in this circuit should also be 10 kiloohms. You should not use a lower value. The power rating of the resistor is not important. You can even use a 0.14 watt resistor like this one, as long as it is 10 kiloohms. In the next step, the probe of the power supply to the end of the resistor and the positive probe of the power supply to the cathode of the diode. Then, connect the multimeter probes as follows. Attach the negative probe between the diode and the resistor, and the positive probe to the cathode of the diode, just as shown in this schematic. In this setup, you will observe the voltage on the multimeter. In this setup, any steady voltage you observe on the multimeter will be the Zener diode's working voltage. And this way you can determine the Zener diode's operating voltage. Let's go ahead and build the circuit practically and observe the results. As you can see, we've connected the resistor in series with the Zener diode, exactly as shown in the schematic. Now I'll turn on the power supply and set the voltage to 2 volts so that the operating voltage will start below 3 volts. I connect the negative probe of the power supply to the resistor leg and the positive probe to the cathode of the diode. Then I connect the multimeter to the circuit as shown in the schematic. Is connected to the positive side of the circuit and to the cathode of the diode. I set the multimeter to measure DC voltage. I connect the negative probe of the multimeter to the common base of the diode and the resistor. Now after making the connections, I will gradually increase the voltage from the power supply. As you can see, we are also observing the output voltage of the power supply on the multimeter. In this test, when a specific voltage becomes constant on the multimeter despite increasing the voltage from the power supply, that voltage is the Zener diode's working voltage. Now let's check what the Zener diode's working voltage is. I will slowly increase the voltage of the power supply. 6 volts, 7 volts, 8 volts, 9 volts, 10 volts. As you can see, the multimeter stopped at 12 volts and didn't go higher, even though the power supply voltage is set to 15 volts, and I increased it to 17 volts. But, as you can see, the voltage displayed on the multimeter is fixed at 12 volts. I will go through the process again from the beginning. Pay attention, I will lower the power supply voltage back to 8 volts, and I will start increasing the voltage again, which you can see on the multimeter as well. Even though I increased the voltage again, and even reached 18 volts, you can still see that the multimeter reads 12 volts. This voltage across the Zener diode does not go higher than 12 volts. So from this test, we determined that the operating voltage of this Zener diode is 12 volts. In other words, the working voltage of this Zener diode is 12 volts, and we were able to easily identify the Zener diode's operating voltage. You no longer need to worry about reading the numbers on the Zener diode, as you can easily determine its operating voltage using this simple test method. The 10K ohm resistor in this circuit is crucial because it limits the current flowing through the Zener diode. Without this resistor, too much current could flow, potentially damaging the diode. It ensures that the diode operates safely and prevents excessive current from burning it out. If we don't include the 10K ohm resistor, a short circuit could occur, causing the Zener diode to burn out. Without the resistor, we wouldn't be able to perform the test correctly. That's why using a resistor is essential in this setup. It helps limit the current, and it's important to use a resistance value of at least 5K ohms, with 10K ohms being the preferred choice to ensure safe operation and accurate results. As you can see on the power supply, the current draw is controlled due to the presence of the resistor. This ensures that a short circuit does not occur, preventing both the resistor and the Zener diode from overheating. Thanks to this setup, we can perform the test without damaging any components, keeping everything safe and functioning properly. I hope this tutorial has been helpful, and now you can easily determine the operating voltage of various Zener diodes using this method. Until the next practical tutorial, goodbye.